So going back to the statement of theorem 3, we showed that if the decoder at time n is the same for two channel sequences Vn-1 and Wn-1, then future decoders and future encoders for all the sequences that get mapped to these two channel sequences are the same. So if additionally the encoder at time n for these sequences that get mapped to Vn-1 and Wn-1 are the same, it means that encoder and decoders for all time n are the same. For all future times are the same. So in other words, mappings for the encoder and decoder at time n is sufficient information for determining the codec for future times. And the notation I'm using here is, in the paper, is slightly different from the video that I sent earlier. But just to recap, I think we can look at that one more time. So in theorem 1, I showed that given the encoded sequence and the last symbol, the future encoders are independent of the first n-1 source symbols. In theorem 2, we showed that given the encoded symbols or channel symbols up to n-1 and the encoding function at time n, the future encoding functions is independent of the source sequence up to time n. And theorem 3, the version that I have in the paper, basically shows that states that I should put it this way, that encoder and decoder for future is independent of original source sequence, the first n-1 source symbols, given the decoder, and then I add encoder to make it gamma n and lambda m to be sufficient statistics for determining the optimal codec going forward and create the Markovity, the Markov structure of the optimum encoder.